Imagine a mind that never sleeps, capable of reading every book ever written, analyzing every medical image ever captured, and writing flawless code, all in the blink of an eye. This is not science fiction, but the reality of artificial intelligence, a silent revolution reshaping what it means to be human. For decades, we defined technology by the tools we built to extend our muscles. Today, we are building tools to extend our minds. To understand where this revolution is taking us, we must first look beneath the digital hood and see how these artificial minds are actually constructed. Historically, computers were obedient servants. They did exactly what programmers told them to do, line by line, through rigid rules. If a computer needed to identify a cat, a human had to program definitions of ears, whiskers, and tails. This approach was fragile and limited. The breakthrough of modern artificial intelligence, specifically machine learning, flipped this paradigm. Instead of giving the computer rules, we give it examples and let it figure out the rules for itself. At the heart of this shift is the artificial neural network, a mathematical structure loosely inspired by the biological neurons in the human brain. Imagine thousands of digital nodes arranged in layers. When an image of a cat is fed into the input layer, it is broken down into numerical values representing pixels. These numbers pass through hidden layers, where mathematical operations are performed. Each connection between nodes has a weight, which determines how much influence one node has over the next. As the signal travels to the output layer, the network makes a guess. In the beginning, this guess is terrible. It might look at a cat and guess it is a bicycle. But this is where the magic of training happens. Through a mathematical process called backpropagation and gradient descent, the network calculates how wrong it was. It then sends an error signal backward through the network, adjusting the weights of every connection just a tiny fraction. By repeating this process millions, sometimes billions of times using massive supercomputers and vast data sets, the network self-corrects. It slowly tunes itself until its guesses become incredibly accurate predictions. In recent years, this technology has leaped forward through architectures known as transformers, the foundation of modern large language models. Unlike older systems that processed data word by word, transformers use a mechanism called self-attention. This allows the model to look at an entire sentence or document all at once, understanding the context and relationships between words regardless of how far apart they are. When you type a prompt, the AI is not thinking in the human sense. Instead, it is using highly sophisticated statistical probability to predict the most logical next word, sentence, or paragraph based on patterns it learned from reading a massive portion of the internet. This brings us to the urgent question keeping economists, artists, and engineers awake at night. Will this technology take over human tasks? The short answer is yes, but the nuance is profound. AI excels at pattern recognition, processing vast volumes of data and executing repetitive digital tasks. Jobs that rely on routine cognitive labor, like basic data entry, standard legal document drafting, and even certain types of software coding, are already being automated. Yet, this is not necessarily a story of human displacement, but of evolution. Historically, technological shifts have destroyed jobs while creating entirely new industries. The automated teller machine did not eliminate bank tellers. It changed their role from cash counters to financial advisors. Similarly, AI is poised to become the ultimate cognitive co-pilot. By automating the mundane, it frees humans to focus on what we do best. AI can analyze 1 million medical scans in seconds to find anomalies, but it cannot deliver a diagnosis with empathy, sit at a patient's bedside, or navigate the complex ethical decisions of healthcare. It can generate beautiful digital art, but it lacks the lived human experience, pain, and triumph that give art its soul. The tasks most secure from AI takeover are those requiring deep emotional intelligence, complex physical manipulation in unpredictable environments, and high-level strategic creativity. As we move forward, the most valuable skill will not be competing against the machine, but knowing how to collaborate with it. The future belongs not to AI alone, and not to humans alone, but to the synthesis of both.